All right. Welcome back, everyone. Ready for another deep dive?
Always ready.
Awesome. Today we're tackling C Sharp, and I'm particularly excited about this one. We actually have some notes from a listener who wants to, well, learn C Sharp.
That's great. Always happy to help someone start their C Shard journey.
Right. And we also have this super helpful document called C Sharp Deep Dive Tutorial Notes to guide us. Our mission is to help our listener and all of you really get a handle on what C Sharp is, what it can do, and just how it all works.
Sounds like a plan.
So let's kick things off with the basics. What is C Sharp in the simplest terms?
Well, at its core, C Sharp is a programming language. It's how you tell a computer what to do, except you're not speaking in binary code, but in a language that both humans and computers can understand.
Ah, so like a translator between us and the machines.
Exactly. And C Sharp was specifically developed by Microsoft. One of the key things about it is that it's object-oriented, which we'll get into later, but it basically means it's really good at organizing and structuring code.
Okay, object-oriented, got it. Now, the tutorial kept mentioning .NET, and I gotta admit, I always get those two mixed up. What's the connection there?
Think of it like this. .NET is like the stage, and C Sharp is the performer. .NET provides the environment and the tools that C Sharp needs to run and do its magic.
Ah, so C Sharp's the star of the show, but it needs that .NET stage to really shine.
Exactly. And there are different versions of .NET, like .NET Framework, which is specifically for Windows, and .NET Core, which can run on different operating systems. But these days, we have .NET 6 and later versions, which bring everything together into one unified platform.
So .NET 6 is like the ultimate stage where everyone's invited. I like that. But okay, let's bring it back to our listener and why they might want to learn C Sharp. What are some of the cool things you can actually build with this language?
Oh, the possibilities are pretty much endless. Web applications are a big one, things like websites and online services.
Like if our listener wanted to build that amazing to-do list app they mentioned in their notes?
Exactly. C Sharp would be perfect for that. But it's not just web stuff. You can also create desktop applications, the kind of programs you install on your computer. You can even build mobile apps for phones and tablets.
Wow, so pretty much covering all the bases there.
Mhm.
Anything else? What about games?
Yep, games too. C Sharp is widely used with the Unity game engine, so if you've ever dreamt of making your own video game, C Sharp is a great language to learn.
Okay, I'm sold. C Sharp sounds like a serious powerhouse.
Yeah.
Now, the tutorial even walks through how to get started, and it seems pretty straightforward. Visual Studio, or VS Code, is your code editor. Installing the .NET SDK.ujackation, you can even create a basic Hello World program with just one command. I remember when I first started learning to code, just getting that Hello World to show up felt like a huge accomplishment. Did you have any aha moments when you were starting out with C Sharp?
Oh, definitely. One that sticks out is memory management. In some older languages, you had to manually keep track of memory usage and free up space when you were done with it. But C Sharp has this amazing thing called garbage collection that does it all automatically.
Whoa, so it's like C Sharp has a built-in cleaning crew that takes care of the memory mess. That sounds way less stressful.
All right, it frees you up to focus on the more creative parts of programming.
Love that. So moving on to the building blocks of C Sharp, the tutorial dives into variables. I remember when I was starting out, variables always trip me up. What clicked for you?
The way I finally understood it was thinking of variables as boxes. You have different types of boxes for different types of things, like words, numbers, or true-false values. And each box gets a label, which is the variable name.
Okay, so like int age equals 25 means you have a box labeled age holding the number 25.
Exactly. And C Sharp gives you these different data types to work with: int for whole numbers, string for text, bool for true or false values, double for numbers with decimals. And then you can use these variables throughout your code to store and manipulate data.
So variables are like the essential ingredients for our C Sharp recipes. And speaking of recipes, the tutorial shows how to use if statements to make decisions in your code. That's where the logic and flow really start to come in, right?
Absolutely. If statements allow your program to respond differently based on certain conditions,
Yep.
it's like saying, if this is true, then do this. Otherwise, do something else.
I see. So it's like creating branching paths for your program to follow depending on what's happening. Now, where C Sharp gets really powerful, at least from what I've heard, is object-oriented programming, or OOP. Sounds kind of intimidating.
It's a different way of thinking about programming, but once you get the hang of it, it's incredibly useful, especially for larger projects. The basic idea is to model things in your code as objects, just like objects in the real world.
Okay, can you give me an example? Let's stick with our to-do list app.
Sure. In OOP, you could define a task object. And this object would have properties like a title, a due date, a priority level, whether it's completed or not.
So it's like a blueprint for what a task looks like in our app.
Right. And that blueprint is called a class in our app. So you have the task class, and then you can create multiple instances of that class, each representing a different task on your to-do list.
Ah, I'm starting to get it. So it's like having a cookie cutter for a task. And you can use that cutter to make as many individual task cookies as you need.
That's a great analogy. And OOP also has these powerful concepts like encapsulation, inheritance, and polymorphism. Encapsulation is all about bundling data and the methods that operate on that data into neat packages.
So like keeping all the task information and actions together. Makes sense.
Exactly. Inheritance lets you create new classes that are based on existing ones, inheriting their properties and behaviors. So you could have a work task class that inherits from the general task class, but adds extra fields like project name or team members. And then polymorphism lets different types of tasks respond to the same commands in different ways.
Wow, that's pretty mind-blowing. The tutorial even has code for a car class. It shows how to define the car's properties like color, make, model, and even methods for things like starting the engine or accelerating.
That's a classic example of how OOP brings real-world concepts into your code.
Okay, so we've covered variables, if statements, and OOP. What other C-sharp tools does our listener need in their coding toolbox?
Well, for more advanced interactions, there are things like delegates and events, which let different parts of your code communicate with each other. For example, in your to-do list app, when you mark a task as complete, that could trigger an event that updates the user interface.
Ah, so events are like signals that something has happened, and delegates are the messengers that carry those signals.
You got it. And then there are lambda expressions, which are basically a shorthand way to write functions, making your code more concise and often easier to read.
Now, one thing that really caught my eye in the tutorial was LINQ. They called it a built-in search engine for your data, which sounds incredibly useful.
LINQ is amazing. Imagine you have a list of hundreds of tasks, and you need to find all the tasks that are due today. With LINQ, you can write a single line of code that does that for you, filtering the list based on the due date.
Whoa, so instead of writing a bunch of loops and conditional statements, you can just use LINQ to pinpoint exactly what you need. That's seriously powerful. And speaking of data, software isn't just about logic and calculations. It's about working with real-world information. How does C# handle that?
C# has a bunch of built-in features for working with data. It has collections like lists, dictionaries, and arrays for organizing your data. And it also makes it super easy to work with files. You can read and write text files with just a couple lines of code. The tutorial even shows a simple example of writing "Hello World" to a text file.
See, you're already a file-writing wizard. Now, the tutorial mentions this thing called the using keyword and says it's super important for resource management. What's that all about?
Ah, yes, using is all about cleaning up after yourself. Whenever you open a file or connect to a database, you're using up resources. The using statement ensures that those resources are properly closed and released when you're done with them, even if there's an error in your code.
So it's like an auto cleanup feature that prevents memory leaks and other nasty surprises.
Exactly. It's one of those things that might seem small, but it can save you a lot of headaches down the road. Now, we've covered a lot of C# features, but the tutorial goes even further, talking about design patterns and best practices. It feels like we're moving into the realm of master-level coding here.
Right. What are these design patterns and why are they so important?
Design patterns are basically proven solutions to common problems in software development. They're like blueprints or templates that you can use to structure your code in a way that is efficient, maintainable, and understandable by other developers.
Ah, so instead of reinventing the wheel every time, you can use these pre-built patterns to solve common challenges.
Precisely. And the tutorial gives some specific examples like the singleton pattern, the factory pattern, and the observer pattern. Each of these patterns has a specific purpose and a well-defined structure. And then there are the SOLID principles, which are guidelines for writing better, more maintainable code. SOLID stands for things like single responsibility, open closed, and so on.
I'm sensing a theme here. It seems like C# really encourages a structured and well-organized approach to coding.
Yes, absolutely. And that structure pays off in the long run, especially as your projects grow larger and more complex. It makes your code easier to understand, modify, and debug, and it helps you avoid creating a tangled mess of spaghetti code.
So we've written this awesome, well-structured C# code. What happens next? How do we actually build it into a real application that people can use?
That's where the final stages of development come in building and deploying. The tutorial walks through this process, explaining how to compile your C# code into an executable program and how to package it up for distribution. There are different build configurations like debug mode for testing and release mode for the final product.
So debug mode is like the rough draft where you can make changes and test things out, and release mode is the polished final version ready to go live.
Exactly. And then the tutorial mentions this command called .NET Publish, which bundles your application into a format that can be easily deployed to different environments.
Okay, and what about Docker? I've heard that word thrown around a lot in developer circles. How does that fit in?
Docker is amazing for deployment. It lets you package your application and all its dependencies into a container, which is like a lightweight, portable virtual machine. This makes it super easy to deploy your application to different servers or cloud platforms without worrying about compatibility issues.
So Docker is like a magic shipping container that ensures your app arrives safely and runs smoothly wherever it goes. I love that.
Yeah, it's pretty slick. And the tutorial emphasizes that mastering all of this takes time and dedication, but it's a rewarding journey.
Well, we've covered a ton of ground today, from the absolute basics of C# to some pretty advanced concepts. Any final thoughts for our listener as they embark on their C# adventure?
C# is a powerful and versatile language, and there's a fantastic community of developers out there to support you. Don't be afraid to experiment, explore, and ask questions. And there are tons of great resources available online, including the official Microsoft C# documentation and John Skeet's book, C# in Depth, which is like the C# Bible.
Those are definitely some resources to add to the reading list. And to our listener, we can't wait to see what amazing things you create with C#. Now, before we wrap up, I have a question for all of you. If you could use C# to build anything, no limitations, what would it be? Let us know in the comments below.
That's a great question. I'm already thinking about all the possibilities.
Me too.
Too.
Until next time, keep coding and keep exploring.